Okay, welcome back. We're on page 679, getting ready to do a demo of curl. I'm basically going to follow what's in the textbook. Okay, so here's what they want you to do. They want you to do curl. Oops, help if you get focus here. So curl, and then I'm going to give it the minus S option, the minus V for both, and I'm going to tell it that I want to ignore a lot of the stuff. Remember dev null, which is a way of saying no thank you, I don't want anything. And then I'm going to give it www.imitgray.com. Let's just see what that does. Okay, so what this basically does is this gives me the headers, okay? The headers which you typically don't get to see. So let's look at it. All right, so it built a URL. It resolved the name using DNS to come up with the IP address. It has its delay setups, and it does the connections and blah, 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 blah. And then, see the little arrow? I'm sending it a GET request, and I'm using HTTP 1.1. I am not using HTTP 2, just saying. And then it's to that host, and then it's telling me, sending it to that I want something, here's what I want, here's who I am, and here's the kind of things that I will accept, okay? And then it responds, you can see back the arrow going back, with a 200, and a 200 means okay. Remember that? So your request was okay to me, and the type of content that I'm going to send you is pure text or HTML, and the last time this was modified was quite some time ago. And here's a tag, and here's a server, and blah 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 blah. And then of course it should have sent you 2,591 bytes of data, but I didn't ask it for that. Okay. So I'm going to do this again, except I'm not going to do any of this other stuff. I just want to, instead of seeing all the headers, I want to be able to just see that data that it talked about, the 2,591 bytes. So what this basically did is, this is not a web server, which means it did not interpret the HTML tags in there. That's not what it did. All it did was just went and fetched it. Okay, so inside your browser, there's a go get the stuff part of the browser. And then the second part of the browser is, oh, now that I've got it, how should I render this on the screen? Oh, that should be a paragraph, and oh, that should be a table. And inside that table is a bunch of rows, and over here is a script that we need to run, right? And so pulling the data from the server is kind of just text. And then after the text is received, then your browser goes back and renders it on the screen so it looks pretty, because we like things that are pretty. Okay. So HTTP 1.1 includes a feature called connection reuse. You may have seen that, where it says, hey, the connection is still open, which is good. Now, HTTP 2, which we're not currently using here, includes full multiplexing, and it's not necessarily sequential. In other words, I don't necessarily, in this one, I basically have to ask for, the first part and the second part and the third part. With multiplexing, I can ask for 4 or 5 parts, and they can arrive in any order. Like, for example, the short one may finish first, right? And then the longer one's going to take longer. Makes sense? Okay. So that type of multiplexing means you get the data faster, but you have to reassemble the parts because they're not arriving in the correct order, perhaps. Okay. So the next thing we talk about is virtual hosts, and this kind of sort of sounds like we're talking about virtual machines and virtual box. That is not what they're talking about when they talk about virtual hosts in a web server environment. So kind of be paying attention. So my web server, wherever the heck it is, I'm sure there's probably, I'm guessing, probably 40 or 50 other web pages on the exact same server. Okay? So when I type in www.imit-gray.com, it goes to, behind the scenes, it goes to server number 42. When somebody types in www.kumquat.com, it's possible it goes to the exact same server 42. Okay, so how does server 42 understand that this request is for that web page and this other request is for another web server on the same physical server? Okay, so that's what virtual hosts mean? A single physical server is serving completely different. I don't know anything at all about kumquat.com. I don't have permissions on their website. And the folks who are administering kumquat.com don't have anything to do with my website. They're completely separate. In fact, we could be competitors to each other, right? Okay, cool. So the way it works is this thing called server name indication, SNI, server name indication. And every single browser understands that. You saw it in the curl when we did that guy. In fact, let's just do that guy again. So when I ask for the host, see when I send it the host guy, I'm specifically asking for something. And the machine says, let me translate that to probably both a machine and a directory, okay, behind the scenes. Because if one server has got like, I don't know, 40 websites on it, it's probably in 40 individual directories, right? Don't you think? So all I have to do is tell it. It has a map of this equals this directory, and kumquat equals this directory. That's server name indication, SNI. So all browsers support SNI. It's been around for quite some time. It's just that most people haven't seen it. Okay, let's go over the web software on page 682. So here's a goofy example of what one of these things look like. So typically the parts of a server. Okay, you have an application server, which means I'm running like a script of some sort. I have a cache, which means when people ask for something, if I don't have to necessarily go to the disk and read it over again, because I've already read that once, like in the last 5 seconds, somebody came and did this, so I'm just going to pull it off the cache to speed things up. Kind of makes sense. A load balancer, which means I have more than one web server, and so when a request comes in, it goes to this one, and the next one goes to that one, next one goes to this one, next one goes to that one. And then an application firewall. Now this is where you would do some of that inspection kind of thing. We're not talking about a full-blown thing. We're talking about just inside the software that runs the web is a way that you can say, I don't want to allow the delete command, for example. And then, of course, the actual honest-to-God real, web server piece. Apache being one of the ones that we're probably going to end up using. Okay, so a firewall, load balancing, cache, web, and the application. Here's kind of how they all fit in there. So an inbound request coming in goes through the application firewall. It hunts for things that like, no, you can't do a delete request. And then it goes to the load balancer who figures out which one I should send it to. And then the caching says, wait, I don't need to go get that. I already have that in my cache. And then it goes to the web server. And then perhaps it goes down to the application server who like runs a query on a database or runs some sort of a PHP script or something. And then that works its way back up the chain as shown here. Okay, so some of the features of all this is just this kind of a bullet list. Let's just go through. So allowing virtual hosts, yeah, that's fairly common. Almost all of them are going to do that. Handling TLS encryption, yeah. That you're probably going to have to go to a certificate authority and get an SSL certificate. Now, see, I said SSL, and I probably should have said TLS. But you have to get a secure HTTP certificate and install it on the web server so it can do the encryption and decryption of the packets going back and forth. Cool. Logging and tracking, that makes sense. You want to keep track of who's going in. And by the way, there is some fantastic things. For example, one of the things you can do from Google is you can go to Google and say, hey, I want to instrument my web page. And they're going to say, well, here's a code that we need you to put in your web page. I guess it's a way of proving that you are the owner. So they give you this god-awful string. You go to your web page and you go up to the header and you add this string into the beginning. And then what they're going to do is they're going to start looking at every single request going through there. And so they're going to end up telling you, okay, 14% of your people are speaking French, and 18% of the people coming to their website are in the Western Hemisphere, and here's the time zones, and here's the languages that they're using, and here's the countries they come from, and here's how many Google requests. I mean, tons and tons and tons of instrumentation. Now, what we're talking about here is the local instrumentation. Like, here's a request, and anytime there's a failure, you probably need to go look at. So, for example, I don't know, let me give you a classic example. So, I put my web page together, and I'm very proud of it, and I send it out there, and I realized that I misspelled one of the words in a hyperlink, and I go, oh man, that sucks. You know, I before E except after C, so I go in there and I change it. And then I end up breaking the link because I changed the URL, but I didn't actually change the name of the web page. And so I go look at my logs and I see all this, you know, file not, you know, a bunch of 404s. Hey, you know, not found. I go, what the heck's going on? Oh, darn. So it kind of makes sense to go look at your logs to see if things are working. Cool. All right. Basic authentication. The website can do basic authentication where you actually give it a name and password, but I tell you the truth, that's, ooh. You know, a lot of people, that's a little squirmy. There's other options that we'll talk about later. Routing web requests. I have a web request for something, so I need to push it over to the right machine or whatever. And then execution of dynamic content. Most websites, of course, are not static websites. There's an awful lot of stuff going on. Maybe you even saw, this is kind of a stupid example, but in here, I have a JavaScript thing. So the last edited part actually runs a JavaScript that goes and gets the date and then displays the date onto the screen. And so I don't have to maintain that in the web page. So that's kind of what we're talking about. Okay. So there's two major software packages that do this. An older one called Apache. That's the one we're going to use. And the other one is called Nginx. This is kind of weird. Nginx, but it's spelled Nginx. Okay, Nginx. I guess they were just, I don't know, trying to be funny. But anyway, Nginx. Those are the two. Nginx is actually probably better and slightly more popular than Apache. Apache has been around for quite some time. So I'm suggesting that for our homework assignment, we're going to use Apache. Okay. So load balancers, we mentioned that one of the features of the web application stack was load balancers. And there's lots of ways you can do this. One of the ways you can do it is incredibly simple. Whoops, I didn't mean to do that. One of the things you can do is what's called round robin. So I have 3 web servers. So the first request goes to the first one. The second one goes to the second one. The third one goes to the third one. The fourth one goes to the first one. So it just goes in order. It goes first, second, third, first, second, third, first, second, third. That's a very simple way to do load balancing. In fact, that is probably the simplest way to do. It's simple. It costs you nothing. There's no fuss. It's pretty doggone easy. The only problem with that kind of thing is if one of the servers goes down, I have to go back to my load balancer and tell it that the server went down. Okay, so the dynamic style load balancers can use kind of sort of the same approach, but they have to have like a heartbeat. In other words, they'll check before it sends it to the first one, second one, third one. It's going to say, "Hey, are you guys still around?" Okay, so you can see how that would be a little better. And then the other one is load equalization, where look, server number 2 is I don't know, you must be doing a backup on it or something, because man, its CPU is spiked. So we're just not going to send requests to server number 2 for a while. I'll send them to 1 and 3, but I'm going to ignore server 2 because it looks like he's under a lot of strain. And then, of course, you can just do partitioning. For example, your request is coming from the eastern United States, so we're going to send it over here. Oh, your request is coming from the western United States, so I'm going to redirect you to another server on the western coast. Doesn't that make sense? That my load balancing would also pick the server. If, for example, these don't all have to be in the same location. Pick a server that's geographically closer to me. Would that be cool? Okay, this is a good place to stop for the 15-minute mark. You know how this works.